Real programs juggle a lot at once. Many connections, files that aren't ready yet, background jobs. Kaappi gives you two ways to do concurrency. And today we take the light-friendly one, fibers. They're so cheap, you can spawn thousands of them, and they talk to each other over channels. Import Kaappi fibers. Spawn takes a function and runs it as a fiber, a tiny independent task. This one sends a message down a channel. Back on the main line, channel receive waits for that message and prints it. Hello from a fiber. A channel is a handoff point between fibers. Channel send drops a value in, channel receive takes one out. If the receiver isn't ready, the sender waits. If there's nothing to receive yet, the receiver waits. That waiting is the whole trick. A parked fiber costs almost nothing, and Kaappi just runs someone else in the meantime. Chain them, and you've got a pipeline. One fiber is a worker. It pulls a number off the jobs channel, squares it, pushes the result, and whoops forever. Another fiber feeds it 2, 3, 4. The main line collects 3 results, 4, 9, 16. A producer and a consumer, coordinated entirely by channels. No shared variables, no locks to get wrong. Here's the cooperative part on screen. 2 fibers, each printing its letter and then sleeping a beat. Watch the output. AB, AB, AB. The moment a fiber sleeps or waits, it steps aside and the other one runs. They take turns, automatically on a single thread. Fiber join just waits for a fiber to finish. Swap 2 fibers for 10,000 and nothing about this changes. They're that cheap. And that's exactly why fibers shine for input and output. When a fiber reads from a socket or a file and the data isn't there yet, it parks, just like it did on that sleep. And Kaappi runs other fibers until it's ready. One thread can look after thousands of slow connections without any one of them blocking the others. That's how Kaappi's web server handles many clients at once, all on a single thread. So, fibers are your tool for doing lots of things that mostly wait. Network calls, file I/O, event loops. They all share one heap, so passing data between them is cheap. And they run everywhere Kaappi does, including the sandbox and the browser build. What they don't give you is raw parallel compute across cores. For that, you want real threads. Fibers. Spawn as many as you like. Let them talk over channels, and Kaappi schedules them cooperatively on one thread. Lightweight concurrency, no locks, no fuss. Next episode, we use every core in your machine with real operating system threads. Thanks for watching. Subscribe for more Kaappi.